Hi, my name is Warner Chavez, and today we're going to talk about the first in a series of 3 videos on the most underrated features of SQL Server 2014. And the feature for today is delayed durability. So what is delayed durability? In order to understand that, first we're going to go over what is normal or full durability in SQL Server today. So when a client application does a transaction, it'll send that request over to the database. The database will do the change in memory on the server, and then this change will get propagated to the actual permanent storage that the database uses. Now what happens now today on a fully durable transaction is that from this call all the way where it moves out here, the return to the application control does not happen until it's been hardened on the hard drive. Now, what is delayed durability then? It's a very, very small change that has a big impact on the database. What happens with delayed durability is that the information keeps flowing this way, but control to the application gets returned as soon as we make the change in memory. That's what we call an asynchronous commit. So why do we care about delayed durability? Well, the reason we care about it is because waits on the transaction log get a lot shorter because we're not waiting all the way till the end. We're actually giving control one step before we used to do it before. Now, the other reason why we would care is because when we do it this way, the I/O operations that happen to the log sometimes can be really small and really quick. Let's say we have 6,000 requests to write something. Then when we do it in fully durable, it's 6,000 different writes to the hard drive. However, when we do it through delayed durability, these same 6,000 requests will actually get buffered into memory and then all get pushed into the hard drive. So when can we use delayed durability? Well, delayed durability is not for data that you want to be holding in a really consistent, durable way. So for example, bank balances, orders, sign-ons on a website is not something that you're going to want to use on something that cannot tolerate data loss. Why? Because what happens is that SQL Server will write here to the log buffer in memory, and then at some other point in time will actually harden the transactions. That some other point in time can be when the log buffer gets filled up, when a checkpoint happens, or also when an actual durable transaction happens and it flushes everything to hard drive. The problem is, if a restart happens when we've already are here at this stage, but we're not here on this stage yet, then we might lose the changes that were done here in memory. So, for example, what is data that is good to use with delayed durability? Temporal tables, any temporal data that you can easily recreate, intermediate stages of ETL, for example, a query that is loaded into a temporary table that we're going to change and then we're going to put into a permanent table. That intermediate table, since it's easy to just reload it, we can do it with delayed durability. Sensor data, for example, when let's say we have a sensor that produces many different data points per minute, but those individual data points, each one is not that important, so we can actually tolerate to lose one as long as we have the majority of them. That's when really delayed durability shines, because we can do that as fast as possible, and then we don't have to worry about, if we lose one single record in memory. So how do you activate delayed durability? It's very easy. There's an option on the database level that you can activate the delayed durability to be either allowed, to not be allowed, or to actually be forced on the entire database. There's also the option to do it per transaction, so you can write your transactions either in natively compiled store procedures or just in normal T-SQL like you do today, and you just have to specify delayed durability equals on or delayed durability equals off. Okay? In the next 2 videos in the series, now we're going to talk about the new partition operations in SQL 2014 and parallel selecting to implement that in SQL 2014.